Okay. Good morning, everyone. So, in the last class, we left one problem unfinished. So I'll just quickly finish that and then move on. Okay. So this was the problem where we wanted to give a character as input and we wanted our program to print immediately its ASCII value, right? But then what was happening? It was printing 10. Yeah. So suppose I give some character, it is printing additionally the ASCII value of new line also, right? It is printing the ASCII value of the character, but it is also printing ASCII value of new line, right? So yeah. So here what is happening is it is taking as if you are entering two characters, the character and the new line. Now you can give more than one character at a time. You see all these DFHS, all these characters you can give. It reads each character and prints its ASCII value. You see? So when you enter the character and the new line, it's as if you're entering two. So let's modify the code a little bit. You see, I mentioned in last class that the delimiters, if you specify the delimiters, it expects those delimiters to be present. Like if you give commas, it expects comma to be present. If you give empty space, it expects empty space to be present. All right. And if you give a single space, empty space, it indicates not just empty space, but it indicates entire white space characters, spaces, tabs, new lines, all these things can be indicated with a single space. Okay. Now I'll put a space before this %c outside the while loop, and inside the while loop also I'll put a space before the %c. So what does it indicate? You ignore all the empty spaces which you get, be it spaces, tabs, new lines, whatever they are, ignore them, and whatever non-white space character you get, store it in %c, store it in ch. Okay. So let's see how it works. Now I give, you see it's printing only that ASCII value. I entered enter button as well. I pressed enter button as well, but it's not printing its ASCII value. Okay. Because it's considering new line as a white space character. Okay. Now it's waiting for the next character. Some non-white space. Now you give any number of non-white space characters, it will read all of them and print their ASCII values. Okay. Here it is reading one character at a time. It is going in the while loop. For every character it is reading, here it is going in the while loop. Like here it is reading S, going in the while loop, printing S, and then reading next D. Again going in the while loop, printing D, then reading H, and so on. Okay. So for every character here, it is reading and printing, reading and printing. All right. But when you enter a new line, that is being counted as a white space character. Okay. So that white space character is sort of skipped because you put a space before %c. So space before %c means it is expecting to skip all the white space characters and then waiting for a non-white space character, and it will store that in ch using %c format specifier. All right. So now if I press Q, it will just quit. Now this program is working fine. Now suppose if I put this white space after %c. Okay. Now what happens? It reads the character. Now it wants to skip all the white space characters after this non-white space character and is waiting for the next character. Okay. So let's see what will happen. You see, it didn't print the ASCII value immediately, right? Why? Because it wants you to finish all the white space characters and enter some non-white space character. Only then it assumes it has read the previous non-white space character. Now suppose if I enter some other character, whatever it is, it will print the ASCII value of T. Okay, suppose I entered G, it printed the ASCII value of T. Now if I enter some other character, it will print the ASCII value of G. Okay. All right. So this is happening because it is waiting for your input, waiting for the next non-white space input. Okay. So this is exactly what happened in the previous lecture also. Earlier, if you remember, I had put %C/n, and then same thing was occurring. It was printing the previous letter's ASCII value, not the current letter's ASCII value, right? Why? Because, so now I press Q. Now if I press any other character, what will happen? It will just quit, because it will read Q now. Okay, it just quit. Okay, so this is happening because it is first reading the character and then reading white spaces and then expecting you to finish entering those white spaces, and it will, until you enter some other non-white space character, it will not move on. Okay, so that is what is happening. Now the point is, whether you enter a single white space or whether you enter /n, both are same. Okay, so /n does not indicate just a new line here. /n also indicates all white space characters. In scanf, not printf. In scanf, if you put a single white space or if you put a /n, it is expecting any white space character to come in its place. So until you finish entering all those white space characters and enter the next non-white space character, it will just keep waiting for the next input, whether it is a single space or whether it is /n in scanf. Okay, in printf, /n is new line, nothing else. Space means space, but in scanf, a single space means representation of all white space characters. A single /n means representation of all white space characters. Okay, so if I do this now, it will behave in the same way. Okay, I press, I can enter a number also. Number is also a character, right? I can enter 8. It will not do anything. It will, no matter how many white spaces I give, no matter how many new lines, white spaces I give, it will not do anything until I press the next non-white space character. I can press something like some semicolon. That's also a character. Now it is printing the ASCII value of 8. Okay, so /n here is not functioning just as a new line. /n here is functioning just as a white space, just as a space. So as space expects all white space characters, new /n is also expecting any white space character. It has to skip all those white space characters. That is what is happening. Okay, yeah, that's it. I
mean, in the program you are using char data type to store the value. Right?
Yes.
And if you are inputting like 10 values at a time,
how
it is going to store like 10 values?
It will not store 10 values. It is reading one value at a time and then printing next value and printing. Yes. See, it's like the way it behaves is slightly different from the way our eyes see. Okay. So his question is, when so let me go back to the proper code. So here I remove this. I put a space before. So if at all you want to skip white space characters, never put it after %C. Put it before %C. Okay. I remove this. Okay. Now it will behave properly. So if I enter a single character, it will read it and print its ASCII value. Okay, right? Fine. Now what he's asking is, if I enter many characters, how is it storing all these characters in a single variable called ch? That is his question. What I am saying is, it is not storing all these characters at a time. It is reading one character and then printing, reading another character and then printing, reading another character and then printing. But for your eyes, it looks as if it is reading all and then printing all at once. Okay, it is reading 9 and then printing some ASCII value. It will read 3 and then print some ASCII value. But for your eyes, it seems it is doing everything at once, but it has to do everything at once because you have given all the characters at once. It can't come back and wait for you to give another character, right? You have already given. What about them? Right? But it is reading one character at a time and printing one ASCII value at a time. That's all. Okay. So imagine it's like you have opened a file. Now you are running a loop. Read character by character. Read the character, print it. Read the character, print it. Okay. Just because all the characters are present at a time in the file does not mean it is reading the entire file at once. It is going into the file, coming back doing something. Again, it's going into the file, coming back doing something. So this so-called terminal std in, when you see stdio.h, standard input output, this is like a file. The space where you are giving the input, it's like a file. Okay. So even though you give many characters at a time, it is like a file which is open to the computer. It is reading and coming back, reading and coming back. Okay. Later, if you get time, if we look at file handling, you will understand that instead of giving a file name, we can also give something called std in, which means it is expecting you to give the input through the terminal and not a file in your hard disk. Okay. So this is also like a file. All right. So this is done. Okay. So now let's look at an example of how to detect whether a number is a prime number or not. Okay, we'll work out some examples today to understand loops better. So what is a prime number? A number which has only one and itself as its factors, no other factors, right? Now, suppose if I have to find if a number is prime number or not using machine, if I want the machine to tell me, I give an input, the machine should tell me, yes, this number is a prime, or no, this number is not a prime number. What should I do? Can someone just tell me the logic? Yeah. Okay. If that number modulus, right. Okay, fine. This clear. Suppose I have, so rather than x, I will just use n in its place. We enter a number n. Now we want to check whether n is a prime number or not. So the logic is simple. You start from 1 up to n. For each of these numbers, you check n mod that number. Suppose if I have an iterator I running from 1 to n, if n mod I is 0, other than for 1 and n, okay, you have an additional factor which is not 1 and n. If you have any such additional factor, so what he's saying is keep track of all those factors, count the number of factors. If the number of factors is greater than 2, then that number is a composite number, not a prime number. Okay. If it is only 2, it is a prime number. Fine. That's one way. Okay. So let's just write that. So let me write the pseudocode. So first read n, and then for I from 1 to n, so read n, and I also say, okay, let me, first step will be set count equal to 0. This will be my count, number of factors. Okay. And then I read n as input from the user. Then I run a loop which says for I from 1 to n, you keep checking. If n mod I equal to 0, what should I do? I increment the count. Count plus plus. Okay. That's it. After that, once you come out of the for loop, if count greater than 2, print n is not a prime. Okay. Else print n is a prime number. Okay. Fine, simple. Now, can we optimize this further? Can we make it more efficient? You just reflect for a few minutes on the problem. You will understand, is our goal to find all the factors of the number or the number of factors of the number, or is our goal just to find whether it's a prime number or not? Just to find whether it's a prime number or not. For that, do we need to find exact count of how many factors it has? No. What do we need to do? Huh?
We can
Huh?
for I from 2 to n instead of 1 to n.
2 to n. Okay, that is one answer. Fine. So instead of 1 to n, we can go from 2 to n. Then why even going up to n? We can go to 2 to n minus 1. Fine. Any more optimization?
So
Sir, in the for when we're incrementing count, then as soon as it reaches like after every time it starts with a for loop, we can put a condition that if count is greater than 2, then you exit and print this.
Very good. So there are you can increase, you can make it more efficient in doing 4 more things. One, you reduce your loop not just from 2 to n minus 1, but you can stop it at n by 2, right? Because 2 and n by 2, if 2 is a factor, anything above n by 2 cannot be a factor. Obviously, you know what is anything above n by 2 cannot be a factor of n, right? As simple as that. Fine. Minimum other number can be 2. Okay. So you reduce your loop from 2 to n by 2. You don't need to check 1. You don't need to check n. For every number, they will be there. So there is no need to check for them. Okay. So reduce your search space. It has come down by half. So half time is reduced. 50% time is reduced. That is one thing. Now you can reduce it further. What? Now within 2 to n by 2, if there is even one single factor, right? That's it. It's done. It's not a prime number. Now you need not proceed further. Why wasting time? You know it's not a prime number. Why checking for other factors, right? So the moment if you know that any number between 2 to n by 2 is a factor of n, you exit the loop. Okay? You break away from the loop. That's it. So let's see. So let's modify the code a bit. So first, now I don't need count because I'm not counting. Okay. So I'll come to this first step in a while. So I say read n, and then I say for I 2 to n by 2. What do I do? If n mod 2 equal to 0, I set a variable here called flag. I initialize it to 0. If I find any, not n mod 2, sorry, n mod I, this is n mod I. Did I write like, yeah, here it's fine. If n mod I is 0, then what you do? You set flag to be 1, which means I found some divisor. I found a factor other than 1 and n. Okay. Now, all I need to do is I exit the loop immediately. I don't need to continue. I don't want to continue with the remaining iterations. Okay. So for that, so now since there is more than one statement, we necessarily need to keep brackets. For that, I use a statement called break. Okay. So this break will let you break out of the immediate loop inside which it is there. Okay. It is not breaking out of the if block. There is no concept of break, continue with respect to if else blocks. Break, continue always apply to loops. Okay. So even if break is written inside if or outside if, it will check the loop in which it is there, not the if block. Okay. So it will break out of the loop. So it will break out of for loop. It will come out. Fine. Now, once it comes out, how do you know whether it came out because it broke in between, or whether it came out because it didn't find any factor? The entire loop is run and hence it came out. How do you check? That is why we have something called flag here. Okay. If it broke in between, then flag would have been set to 1 because flag was 0 initially. The only condition in which flag becomes 1 is only when a factor is found, only inside the if block. So only if the factor is found, flag is changed and it is breaking out of the loop. If a factor is not found, flag will not be changed. It will just complete the loop and come out. So if flag is 0, it means it just completed the loop and came out, so no factor was found. If flag is 1, it means some factor was found and it broke out of the loop in between. So after coming out of the loop, what are you supposed to do? You should check if flag is 1, then print n is not a prime number. Else print n is a prime number. Okay, that's it. Yeah. You can write, if it is a prime number, only that statement you can write inside the if block. Fine. But once you come out, again you don't know whether you came out because it broke and came, or whether it finished the loop and came. Okay. If it finished the loop and came, then you have to write that statement, it is a prime number outside the loop. Okay. Even then, you can't print it without knowing whether it's prime number or not. So you have to check again here. How did it come out of the loop? So anyway, here you have to put the if else condition. Yeah. Okay. So let's quickly code it. So let's say int flag equal to 0, and okay, I also need to declare some n. So scanf %b %n. Now I can also write while loop. I can also use anything. Anything is fine. So I am declaring iterator inside the for loop, so it is visible only inside the for loop. Outside for loop, it will not be. It will vanish. It will disappear. So the scope of this iterator I is only the for loop. Okay, it's called local scope. For int I equal to 0, not I equal to 0. Sorry, for int I equal to 2, I less than or equal to n by 2, I plus plus. If n mod I equal to 0, flag, you see this order is important. If you write break and then flag, it's gone. It won't change the flag. So you should first write all the statements before you want to break, and then write break. Okay, flag equal to 1 and then break. Okay, now I come out of the for loop. Now I check if flag equal to 1, then printf %d is not a prime number. Else printf %d is a prime number. I need not put brackets after if there is only one statement in if condition, or only one statement in else condition, or only one statement in for block. Any block, if there is only one statement, brackets are optional. But for any block, if there is more than one statement, brackets are compulsory. Okay, this is not like Python where just by indentation you know all the statements are below it. No, here brackets differentiate which statement is in which block. Okay, so if there is only one statement in a block, you need not put brackets, the curly braces. But if there is more than one statement in a block, you have to put curly braces. Okay, now let's run it. Some number, let's say I enter 7. It says 7 is a prime number. I enter 31. 31 is a prime number. I enter 4. 4 is not a prime number. That's it. Okay. So this is the use case of break. Fine. So you need not waste your energy in running through the entire loop, even though when you got your work done, right? The moment you know you got your job done, just break out of the loop. You don't need to continue. All right. Now there can be some cases where you want to run the entire loop except in some few cases. Like suppose if I want to print numbers 1 to 100, but I don't want to print only say some two numbers, say 48 and 72, something like that. Okay. Now if I have to use a loop, what do I do? There are multiple ways. One is I run a loop from 1 to 47, and then 49 to 71, and then 73 to 100, because I want to skip 48 and 72. So I need to write 3 loops. No. Another way is I put an if else condition saying that if the number is not 48 or 72, only then you print it. If else condition, that is sufficient. Okay. Another way of doing it is, you see, print statement, if it is only one statement, it's fine, but otherwise there can be a case where we just want to not worry about that printing, we just want to skip them. Okay, so to skip and go to the next iteration, the another keyword is called continue. So let me give you an example. So let me save it as so I just want to print 1 to 100 for int I equal to 1, I less than or equal to 100, I plus plus. I want to print 1 to 100 except numbers 48 and 72. Okay, so if I equal to 48 or I equal to 72, what you do? No, you should not print. Continue. You understand what I'm saying? Now it will print all the numbers except 48 and 72. Okay. So continue means whatever statements are there in the body of the loop below the word continue, it will skip all of them. It will again go back to the next iteration. So what happens now? So first I is 1. If condition is not satisfied, it will come after if condition, it will print 1. Then it will print 2, 3, 4, and so on up to 47 it will print. Now when it is 48, it is if condition is true. So it will enter the if condition, it says continue, which means skip all the remaining statements in the loop. Go to the next iteration. Now I becomes 49. Now if condition is false, so it will come and print 49. Next statement it will go. Okay, so continue can also be put inside a if block, break can also be put inside an if block. Both of them affect the loop, not the if block. Okay, if you put break inside the if block also, it will break out of the loop, not just the if block. It will not stay in the loop, it will break out of the loop. Even if you say continue, it will sort of skip all the remaining statements, not just in the if block, it will skip all the remaining statements in the entire loop and go to the next iteration of the loop. Okay, so let's see the output of this. Now let's see, did it print 48 and 72? 41, 43, see 47, 49, no 48. Okay, and 70, 71, 73, no 72. It skipped them. All right, so break and continue, these are jump statements. It allows you to jump in a non-linear sequence. When you don't have these statements, it just goes in a linear sequence. All the conditional branching things, they are all like allow you to skip some statements and go in a particular direction. If else is like a, in some sense, that is also like a jump statement. It's like, if this is true, you go in this direction, otherwise go in this direction, right? It is skipping in between statements and going in some direction. Similarly, a loop is like a jump statement. Once it is coming to the last statement of the loop, it doesn't go to the next statement, it comes back and jumps to the beginning of the loop. Again, that is like a jump statement, right? Break is like a jump statement. Whatever statements you have in the loop, below it, once you see a break, it will skip all the remaining statements and it will not even go back to the beginning of the loop. It will come outside the loop, jump outside the loop. Okay, continue is a jump statement. In continue, it will not come outside the loop, but for that particular iteration, it will skip all the statements below the continue statement in the loop. It will go back, it will jump to the beginning of the loop in the next iteration. Okay, so this is break and continue. All right. Now let's uh, okay. One more thing, just a simple mistake which most of you make many times. I mentioned it already. Suppose if I put a semicolon here, what will happen? Code won't run. Code won't run not because I put semicolon, but because of a different reason. Suppose if I comment this, okay? So what will happen? Suppose if I say, I don't declare I here, I declared I here, okay? Now I put comment here, okay? I can put this bracket in the next line. What will happen? It will, it will print, it will print 1. Suppose I just change it for you like this. Now what will it do? Huh? There is no statement inside, it's empty. So to say that a loop body is empty, you have to either put a semicolon or you have to put empty brackets. Okay? So both cases are same. Fine. Now, can anyone tell me the output quickly? Huh? 101. The loop is running, but it's not doing anything. It comes out of the loop. I value is updated in the loop. Once it comes out, I value is 101. So it will just print 101 one time. That is the entire output of the program. Because there is no statement inside the for loop. For loop body is empty. Printf is outside the for loop. Okay. So this is what happens when you put a semicolon in place of a semicolon before the opening bracket. This is equivalent to saying this body of for loop is empty. So that single semicolon is making all the difference. It is changing the entire semantics of your program. You intended to print numbers 1 to 100, but it is skipping all of them and it's printing 101. Just because of a single semicolon. And it will not even tell you that it is an error. So you will not be able to debug it easily. Okay. So always keep in mind, don't put a semicolon immediately after a for condition or an if condition. There is no semicolon between the for condition line and the opening bracket. There is no semicolon. Or if condition and opening bracket, or while condition and opening bracket. No, that is why I am telling you again and again, make a habit of keeping the opening bracket immediately after the condition is over, not in the next line. If you make a habit of opening the bracket in the next line, you make it a habit of ending the previous line with a semicolon. That is not a statement on its own. This entire block is a statement. For condition, some block of statements, this entire thing is a for statement. Okay, like if condition statement, that entire thing is an if statement. So you need to keep that in mind. Fine. So it just this for 3 conditions, first statement is over. No, unless you put the body of the loop, the first statement is not completed. Okay, so let's see. It will print 101. It is only a warning, but it's not an error. Just printing 101 because you put a semicolon there. That is equivalent to putting an empty body of statements, empty body of the loop. That's it. Both are same. So be very careful where you're putting semicolons. Be sure that you have ended. You're putting semicolon only at the end of statements, not partial statements. Okay, fine. Now let's move on to printing patterns, nested loops. Okay, So let's quickly write the pseudocode. So why I'm showing you pseudocodes is because always make it a habit to put down your logic on paper first before you code. Once your logic on paper is clear, your coding will be much easier. When you're straight away coding, you are confused between two things, your logic and syntax. So you don't know where to draw the line. Okay, at least keep syntax away for some time, just focus on the logic part is done. Now there's no more algorithm to think of, you just need to convert this logic to syntax. That's it. Okay, so separate these two steps. Fine. Now, yeah. If else in this, if I keep this after the if condition, after the continue statement, it doesn't matter. If I keep it before the continue, this particular if else condition you're saying. So like, what are you saying? Like this. Okay. Okay. Now, if now you tell me what will happen. Why? Okay, because semicolon was there. That's what you're saying. Okay, now semicolon is there. Now it means if else is this if condition is outside the for loop. Now what is the meaning of the word continue? Continue makes sense only when you're inside a loop. Okay, if the semicolon is not there, fine. No, because this condition is inside if condition. This printf statement is inside if condition. Only if number is either 48 or 72, it will come inside. Now suppose I want to print only 48 or 72. Okay, then I first print them and then I say continue. Or I need not even say continue also. It will print because it is inside if condition. It will print only them, even if there is no continue statement. It will not even print. If continue was there before printf statement, it will not even print this. Yes, even if the condition is true, it won't print. It will skip all the statements inside the if block also, not only the for loop. So let's just quickly test it. Doesn't print anything because continue was there before. Suppose continue is there after. It prints only those two. That's it. Okay, fine. Now let's quickly work out some patterns. So suppose if I want to sort of print a pattern like a square, right? Square like, okay, something like some character I take. Okay, I want to print a 3 by 3 square. Just this. This is a loop. I go on printing. 9 things are there. 9 times I want to print. So how do I write this? Huh? Okay, we use a for loop. What should I write? How the pseudocode will look? For I 1, 2, 3. Okay. Printf starts. Print star. Okay. We can use 2 for loops. Now how do I? Okay. First for loop is for column. Second for loop is for row. How do I combine these for loops? One after another or what?
This for one is inside the other.
Good. This for loop, this entire thing should be repeated thrice.
Yes.
So this is, you imagine this is like one statement. Now this statement should be repeated thrice. So this will go in another for loop. So for here. What should I write? Now you should be careful when you are using nested for loops. The variable in the outer for loop should be different from the variable in the inner for loop, because the variable in the outer for loop is visible to the inner for loop. It is inside the outer for loop, so it is still in the scope. Okay, so if you modify this variable in the inner for loop, it will affect the variable in the outer for loop also. So it is always better to use two different variables for both the nested loops. So instead of I, let me say j goes from 1 to 3. Now where here I should give after this, outside this, here I should say print new line. This is inside this outer for loop but outside the inner for loop. Okay, done. So now tell me, the inner for loop prints row or column? Prints a row, right? Star star star. Then next line star star star. Then next line star star star. So inner for loop prints row and outer for loop prints so many rows. That's all. Okay. So let me say 10. Now for, okay, I didn't declare I, so here it has to be int. I can say int j equal to 1, j less than or equal to 10, j plus plus, printf start. Now outside this, I should write printf new line. Okay. Now suppose if I remove these brackets, will it print star new line, star new line, star new line? No, it will still print 10 stars and then new line only once, because I didn't put brackets. If I don't put brackets, only one statement is taken inside the loop. Okay, independent of the indentation. Just because you indented both of them in the same margin does not mean both of them are inside the loop. Okay, so this is same as this thing. No difference. Okay, so let's quickly check it. Okay, fine. Now suppose I want to print not a square. This doesn't look like a square because of the spacing, but it is a square actually. Now suppose I don't want to print a square, I want to print a rectangle. All right. So suppose I want to print a rectangle of 5 rows, and in each row there are 100 stars. Okay, now how should I modify this code? Inner loop should be 1 to 100, 1 to 5. That's it. Let's just quickly do it. That's it. Okay. Now the next interesting thing. Suppose I want to print a circle. Not now. Can you print a circle? Ideal circle? No, right? Yeah. Ideal circle doesn't even exist in computer. It's all pixels. It's impossible. Fine. So we'll come to that. We will start with smaller polygons. Okay, triangle, square, rectangle. Then we can go to pentagon, hexagon. Then you keep increasing the number of sides. Then you will get circle. Okay. So let's not worry about that now. So let's try to print a triangle. So what will be the code for this? Yeah, so exactly what should I write? So here, what you need to do, you need to find a pattern in each row. Okay. Now, let's say this is in this is row 1, 2, 3, 4. Okay. In row 1, how many stars you have? 1 star. In second row, 2 stars. In third row, 3 stars. And fourth row, 4 stars. Okay. Which means in ith row, I stars. All right. Now outer loop will tell me how many rows I have. So here I goes from 1 to, here I have 4 rows, 1 to 4. Inner loop has how many stars? In ith row, I stars. So J goes from 1 to I. Print star and here print new line. So this you are able to do since you know the pattern. Okay. So let's just quickly check it. I will share it. Don't worry. Okay, simple. I goes from 1 to 4, which means 4 rows. And in each row, how many stars? I stars. That's it. Okay. So let's make it slightly bigger. Yeah. Let's make it 40. Okay. You can print as long as you want. You can make it 100 million, whatever you want. Print what? Equilateral triangle, yes. So let's try quickly. Now again, you need to find a pattern there. So 1, 2, 3, 4, 5, 6, whatever. It won't be exactly like this. So here, if you want that, you need to ensure star space star star space star space star like that. Okay. We can do that. Let's. Okay. For now, let's not worry about that. Let me just ignore this for now. Let me make it simple. Okay. Now, what does it mean? 1 star, 3 stars, 5 stars, 7 stars. Okay. Now, how do you print this? Huh? 7 stars. Huh? Huh? See, simple. Anytime a pattern is given to you, first try to find the relation between the row number and the number of stars in that particular row. Okay. Now, how many rows are there? 4. Now, in fourth row, 7 stars are there. What is the relation between 4 and 7? 2n minus 1. So, in ith row, how many stars will be there? 2n minus I stars. Okay. Now, in third row, you have 5 stars. That is 5. 2i minus 1. Okay, sorry. 2i minus 1 stars. In third row, you have 2i minus 1 stars, 5 stars. In second row, you have 2i minus 1 stars. In first row, you have 2i minus 1 stars. But if you just write your for loop like this, it will not print this pattern, no. It will print them from the left margin. So you need to take care of spaces also. Now you also find the relation between row number and the spaces number. Okay. Now in fourth row, 0 spaces. In third row, how many spaces you have? 1 space. In second row, how many spaces you have? 2 spaces. In first row, you have 3 spaces. Okay. So now you tell me what to do. Exactly. So n minus I spaces in ith row. If it is second row, 4 minus 2 spaces. If it is first row, 4 minus 3 spaces. If it is third row, 4 minus 1, 3 spaces. If it is fourth row, 4 minus 4 spaces. That is 0 spaces. Okay. So when you start a loop, when you start a row, you need to have 2 for loops inside the outer for loop. Right? One for loop for spaces, one for loop for starts. So let's quickly do it. Time is up. So I less than, let's say 40, doesn't matter. Now, for j equal to 1 to 40 minus I, okay, print spaces. Okay, now for, now I can use j because this is outside the previous for loop. That previous j is closed with that for loop. If you are not sure, use some other letter. Okay, for int l equal to 1 to l less than or equal to 2I minus 1 L plus plus print start, and then outside these two for loops, let me remove this for now, it's so confusing. Yeah, printf new line. Okay, that's it. Okay, so let's close here. um, let's take attendance.